welcome. Now, if you've seen our videos before, the Breaking Stuff with Joe series, you'll know that every single episode of Breaking Stuff with Joe is special, and you'll know that most of those episodes are very special. So I have to come up with some new adjectives today because today is very, very extra special. We have a fantastic guest in. We have Kent Wilson, the VP of Customer Experience from Bricata, in here today to talk to us about the Bricata tool suite and sort of walk through that product and some of the use cases of it.
Yeah, thanks, Joe.
Welcome to it. So before we get started, Kent, you just want to just elevator pitch Bricata and tell us exactly what it is, what it does, who it's for?
Sure. So Bricata is a network visibility platform and threat hunting platform. We like to tagline it with comprehensive network defense, or network defense platform. But long and short of it is that Bricata is a sensor capability, something that will sit in line or off of a span or a tap in your environment and monitor network traffic. And from that, extract metadata from that traffic, create alerts based on signatures, based on behaviors that we're seeing, based also on some malware advanced techniques. So
sort of machine learning implementation.
Machine learning interpretation. Yeah, exactly right. So math problems. Exactly.
Yeah, math problems, exactly.
So tying that all together then into a analytics platform that gives the network analyst everything they need to kind of run things to ground. So giving them actual full PCAP, allowing them to look at alerts and bring smart PCAP to the forefront. These are small contextual slices of PCAP that are relevant specifically to alerts. All of the metadata is there as well so that they can start to develop some really nice threat hunting techniques, and then being able to use all of that data for different data stacking and different visualizations, all of which is intended to get an analyst to ground truth and making good decisions quickly.
Okay, so your goal is sort of the holistic threat intelligence, just every component of it that you can find and aggregate.
Yeah, and less so the threat intelligence piece, but aggregating all of the network, really network focused, network security in the environment, right?
Sure. Makes sense. And so before we got started, you were telling me a fantastic story, kind of walking through with these slides as sort of a general outline. So we can roll through that if that's something you want to.
Sure, yeah, happy to. So we were just talking about what we see, what Bricata sees when we're working with prospects and when we're working with our customers. We've spent a lot of time working in the government. We've spent a lot of time working with large enterprise customers and starting to work with some of the small, medium business organizations. But one of the big challenges folks have is just network visibility in general. And so I had an opportunity not too long ago to be working with a prospect who will go unnamed here, but they were challenged with just trying to elevate their own security program. And as we were having a conversation about bringing some of the Bricata solutions to play in their environment, we were interrupted by a phone call. And that phone call came from a law enforcement agency that said, excuse me, we are reaching out because your ISP informed us that we're seeing some traffic going to some domains that we know are hostile domains and are actually part of a much larger case that we're working. And we think that this particular threat actor is targeting folks that are in your vertical.
So just this is an absolute nightmare.
Everybody's nightmare call. Yeah, exactly right. And so that was just it too. We get to smell everybody's as the news permeates the room and it travels very quickly. You get to smell everyone's armpits kick off, and I was politely asked to go ahead and leave the room. So I spent that afternoon waiting at a lunch place, and as the day wore on, I finally called back in and said, how are you guys doing? Do I need to reschedule, change some flights? What's going to happen here? And they said, you know what? You may want to think about leaving or rescheduling because I don't think we're going to get through this very quickly. And when I asked what the problem was, they said, well, we're a large organization and actually narrowing down where these requests are coming from has been a little more challenging than we expected. We, on the security side of the house, don't have access to the name servers in the environment.
So the security was just completely cordoned off.
They were just cordoned off. Yeah, exactly right. So we need to get some change control done in order for us to get access to that. We now have that, of course, and what we're realizing is that when the networking team built this out, they decided not to log queries. So that information's not being pumped to the right places, and it was just a bit of an eye-opening experience for them, and certainly something where I got to scratch my head and smile on the other side of that, saying, well, we did just install a network sensor, and maybe what we can do is use our product to help you guys uncover what's going on here.
The ultimate sales opportunity.
It was. I'm actually paying this agent to make phone calls for me, so it's worked out really well. But yeah, so net of all that was that we actually did go back in and we jumped right into the solution. And one of the great things that I don't think people realize is you don't have to have a million different security controls to get visibility. I mean, what's great about a network monitoring solution is that when you are able to extract metadata from that network traffic, it becomes duplicative of a lot of the things that your other solutions or security controls might be logging, or in fact not logging in some cases, right? So so this is a great thing for a security team to own, to operate, and then to be able to review when trying to understand what's going on in the environment. So in this particular case, we were able to within about 5 minutes. So they'd spent 4 or 5 hours trying to figure out.
Long enough for you to build your company for a very long life.
Yeah, exactly right. So they'd spent some time, and then within 5 minutes, we had figured out what the source of the problem was. And so the fun part about this story was actually a malfunctioning security control that was beaking out to some threat intel that it had received. So,
nice.
Yeah, just poorly configured stuff.
And that's something I commented earlier, is that so often in the security world, we're chasing a new fad. Obviously ML and AI is what everyone's talking about. And, advanced persistent threats and all these huge nation state actors. And very commonly in the security world, what really needs to happen is sort of that health and wellness sort of hygiene check for security. And being able to keep track of your information, really know what's happening in your system. And that's sort of what you, I guess, in this story, what you're able to provide with Bricata. Right?
Well, yeah, in that particular case, it really was just sort of the basic foundational pieces of things. And then
giving them the security infrastructure they need just to have a healthy and successful business.
Basic hygiene, yeah.
Absolutely.
Yeah, absolutely.
So you have some slides here for us? You can walk through those, or you can sprint through those, or
I
however you want to
do have some slides here. Yeah, well, the front end of this was a conversation that I had. It's a very simple view of the network tools that most organizations have at their disposal, and kind of helping the people understand what the problem with visibility and what the challenges are around network threat hunting. So again, people troll this term network or just threat hunting in general. It gets levied by all sorts of different companies doing different things. And so I will spend some time defining with you. We can talk about what threat hunting actually means, at least to us. But looking at network visibility, I told that story about the FBI. There I am. The law enforcement. Yeah, so I told that law enforcement story, but when working with larger groups, I was talking to some folks in Nashville a while back ago, and this conversation about where we just said, hey, you're the brand new guy. Everybody's this is back, I want to say November last year. I think GDPR was what was on everybody's mind. So it was this notion of data sovereignty and isolation and things like that. So. Anyways, the notion was that you're the new CISO there, and at the end of the day, you've done a really great job. In 3, 4, 5 months, you've managed to go ahead and knock out all of these huge projects, and you're on track to pick up vulnerability management or whatever that might be in the infrastructure, and everybody's cheering you on and thinking you've done just the most wonderful job. It's the weirdest board meeting you've ever been to because there's this audience on the side, right? And
very large, very young board.
Yeah, right, exactly. And Gus, your security guy, he comes walking in right in the middle of the meeting with all the grace of a guy who's kept in a back room for a reason. And he goes ahead and says, hey, look, we've got a problem. Law enforcement agency just called. They need us to get some information, and I have no idea where to get it. And you can see a few of the board members are starting to get a little annoyed that Gus shows up. And then he sits down right in the middle of the table and brings Jason out.
Yeah, just about every security engineer I've ever met is about how they approach the situation.
And Jason's saying, boss, I'm going to need your computer. I'm running off with it to go do some forensics. And at that point now, the entire audience is staring at you like this instead of with the big smiles you had just a minute ago. And so the question was, do you have the visibility you need to respond to that kind of question? And the vast majority of folks, the answer is no.
Yeah, and that's the vast majority, not just in the small mom and pops who always think of as bad security, but we're talking Fortune 100, Fortune 1000 companies who just don't have the infrastructure or the monitoring in place to have that visibility. Right?
Yeah, that's right. That's right. And I think, the small mom and pops, typically this isn't even something they're thinking about. If they're thinking at all, they're thinking about getting that managed service provider to come in there and do this sort of thing for them.
Yeah, this is sort of an implementation group like 1, 2 kind of thing.
Yeah, absolutely. So, we talked a little bit at this session with the CISOs. We were just talking in big, broad strokes about what are those big visibility challenges. And so, at the end of the day, this is an old problem, but security was never at the forefront of anyone's design when they built out these infrastructures, particularly anything that's got some age on it. Yeah. And access to the controls, they're often siloed. Tools are specific to the infrastructure team or the network team and the security team often can be left out of who lives and controls those things. And then all of the crazy change management, taking weeks to get things done versus being able to move quickly and dynamically.
Yeah, the speed of bureaucracy.
Yeah, exactly right. And then all of that sort of unmanaged or rogue infrastructure that exists out there, sitting under somebody's, Joe's laptop that's sitting under the desk with 30 VMs on it. So, and these challenges on the SMB side are different in that now they're much more resource constrained. So security is not at the forefront of design still, but they don't have a security team, and they've got limited investment capital to do anything with it. So, if we were looking at those challenges, what are the things that are important for you as a company? And it was the big question that is sort of everyone's asking is, what happens if I miss something critical? And then at that point, it's because we're all living in this assumed breach mentality these days, or at least we hope we are.
Yeah, fingers crossed.
To what extent is my network compromised? What other devices have interacted with suspicious devices or suspected devices? What behaviors led to these events, and where did these threats originate? These are all questions that we want to be able to answer. And then I always throw this out here because it was a great statement that a customer actually said to me once, but it was this whole notion of why do we focus on the network? And it's because in the grand scheme of things, logs for my security controls, logs everywhere. If I'm not logging the right thing, I might have this false assumption that I've got something secured or that I have the right data coming in to solve security questions.
I'll sort of assume that a priori knowledge of what the threat might be.
Might be, and that the configuration of the logs is appropriate for getting the answers that you need when there's an issue, right? So we always talk about this: logs can be misleading, but traffic never lies, and that's sort of at the heart of what a traffic monitoring solution provides you. At the end of the day, you're not focused on getting a good log from a security control, but rather just looking at the traffic itself and being able to pull what you need from that traffic. So we talked then about what are the tools that are out there. And I think this is, again, very big broad strokes, but we always talk about IDS being that alarm system. Mm-hmm. So very alert driven, very light on context, but in that way also very easy to store, very easy to manage. PCAP containing everything. Our CEO is a big fan of throwing Z's on the end of stuff.
I noticed that. First time I didn't know how to type on your slides. I was like, oh no, they have one of those.
Yeah, it happens. And I probably should have corrected it before sitting down with you here, but it was a joke that was only funny 5 months ago. It's not funny anymore.
Well, jokes famously get better as they age, right?
Not in this case. But when we're looking at PCAP, and that's packet capture for folks that might, but this idea of a full fidelity replay or a recording of everything that's crossing the wire.
Well, you mentioned that, going back, IDS, for those who don't already know, is an intrusion detection system.
Yes.
It's easy to get lost in acronyms here, so doing our best to spell them out.
But of course, the problem with recording everything is incredible storage requirements around that, and gets very heavy and difficult to index, difficult to look through. Mm-hmm. So you've got that particular piece of things. You've also got this notion of NetFlow, which is this high-level summary data. It's kind of super lightweight. I would say like the equivalent of the guy watching the door and checking people in and out of a building. And then this network metadata component of things. And this is really where I think, from a Bricata perspective, we've really indexed heavily on this piece of it, that we think PCAP is fantastic, but it's just too heavy to manage. And intrusion detection is great, but it's just not. It's just light on context. Mm-hmm. And when you have this nice high fidelity metadata that's out there, you can really start to make sense of things without hanging on to everything. But you have what you need to make good decisions and to understand what's taking place. So that becomes
the essential context.
Yeah, it's the idiot savant you've got going ahead and actually writing meticulously every single thing down that he sees on the camera, right? Nice. So that you can go ahead and look through your list. So, if I reorganize these a little bit in a way that talks about the data fidelity versus the scalability, this becomes one of these conversations that as a CISO, you need to be thinking about, how do I structure?
Where do we exist in that trade-off?
Where do we exist in the trade-off, and what do we care most about? And you'll see, the government spends with unlimited budgets for storage might focus very heavily on these super high fidelity solutions, but
for whom money is no object, all they care about is fidelity.
And so for the bulk of us, I think we all live somewhere in this middle space where, what is that appropriate balance of fidelity and scalability that's going to give you what you need to solve problems. So this was where we would start a lot of people off in a conversation just about their network security and where do I land and what do I think about as I'm starting to approach the different types of solutions that are out there. And when we start looking at these things individually, it just goes on and on and on what you can talk about with respect to PCAP and various PCAP recording solutions and metadata solutions that are out there and intrusion detection systems. So there's a lot to each one of these, but I guess...
So to some extent, the part of what you're offering here is the idea that you have figured out what you believe to be just the right balance of fidelity and scalability. Kind of
no doubt, yeah.
That context.
Exactly. Well, what we found, and one of the big challenges that we were faced with as we were building things out, we had an investor that was very interested in us helping them create a more efficient workspace for their analysts. This is somebody who employs hundreds, if not thousands, of analysts. And their thinking was that we spend too much time pivoting in our chair from one solution to another to try and get to data. That's all network-centric data, so or network facilitated data. So wouldn't it be nice if we could have a single solution and a front end that was really designed for improving and bringing all these different data sources together, correlating the information that's in there, and providing context to people very quickly so that when they get an alert, they don't just know that an alert happened, but they can see all of those other pieces of things.
So the priority sort of there being getting your analyst to ground truth as quickly and efficiently as possible.
Right.
Okay.
Right. So in the end, we've built to solve that problem. And I would say it's interesting because very, very large organizations have their own front end. They have their own very fancy workflows and systems that they've built out that just require data to facilitate those. And in that case, we become the data pump for a lot of that. Yeah.
And that's where you talked earlier about the idea of part of the core component anyways, the idea of the sensor just being on the network to provide that introspection, right?
Right.
Okay, fantastic. So we're through your slides then? We're ready to...
This guy, I'm sure there's more in here, but I'm going to skip it. Yeah.
We have a core understanding of sort of the opportunity cost decisions that we're making and why those decisions exist. So we could jump into the very, very pretty... I have to say, of all the things, of course, as a programmer, I love dark themes on IDEs and everything else. So the first thing that struck me, for those of you who aren't watching this video, just the color scheme on Ricatta, all the security considerations aside, it's just a beautiful tool.
That's wonderful to hear, and I've got a CTO who would be very happy to hear that as well.
Pass along my compliments,
yeah.
Absolutely.
Yeah, we choose tools by their themes as well, so internally, if we can't get a dark theme, it doesn't get used.
Yeah, it's not a real tool.
Yeah.
All right, so we have the tool up on screen. We want to go ahead and just kind of walk me through how, I guess give me the pitch first, then we can walk through sort of how
sure.
an analyst would look at this.
Well, if I were to give you the pitch, and it might even require me to step back to another slide, which I know nobody wants to do, but we think of ourselves as existing with sort of four pillars of execution, with the first being this visibility in an instant, the ability to kind of get a look at your traffic and have it organized in a way that you can immediately see things the moment the sensor is turned on and configured. It's streaming data back to us about what we're seeing. The other is this comprehensive threat detection. So we're leveraging three distinct detection engines on the solution. We've got a signature-based engine that is doing your traditional signature-based IDS. We've got a behavioral detection capability that is monitoring heuristics, exactly, and also extracting metadata. We then also have another solution as we see files cross the wire, we'll reconstitute those files and submit them to a local engine on the box for inspection, and that will do some static analysis very quickly, run some math problems essentially, and determine if
my absolute favorite description machine. It's going to do some math problems and let you know something first.
And that's exactly what's happening here. So we'll then have a determination made as to whether that is this piece of suspected malware or something that we can forget about, and that is all then I guess reinforced or supplemented by having access to the PCAP around those communications. So that is that comprehensive network threat detection component of things. So we said visibility in an instant, comprehensive network threat detection. The advanced malware component of things is another pillar of execution there. And then finally, post-detection actions. So the idea that this information that we're collecting can be moved on to whatever landing system needs to be there for your incident response. We have an interface where folks can work with to perform their own incident response. And finally, API level interactions with the product so you can start to orchestrate things as well. So having said all of that, go ahead.
Oh, I was just going to say, with that in mind, you want to show me a day in the life?
I do.
This tool?
So we can come at this from a couple different directions. I tend to think of most organizations still being largely alert driven. So wanting to spend most of their time having something explain to them the things that they need to look at.
A generally reactive security policy.
Yeah.
Which isn't necessarily how everyone wants to live, but it's how resources permit in a lot of cases.
I think you're saying it better than I did. So, but if I approach this from the alert side of the house and we look at the solution here, we're being provided with a bunch of alerts. These alerts are coming in a way that's pretty understandable for most folks. Severity 1 being things that are critical and need to be addressed immediately. Severity 3 being somewhat informational. The system runs in a 1 to 4 way so that you could have your own things scored as 4 as well. But
so 4 is reserved for your own custom determinations.
Custom determinations, yeah, precisely. So if we're looking at alerts, and I think I explained that there were a handful of different components to the way that the alerts are being created, this can be a little bit overwhelming because you have a big wall of alerts that are kind of thrown at you here. But from an analyst perspective, these all represent a place for me to jump into a conversation with the network. And the alerts that are coming out of the solution are based on signatures, they're based on behaviors, and so in every one of those cases, we've kind of got a story that's being laid out for us right here. Actually, if we look at the order of events here, we've got a system that's been named Sales Terminal 1. That's sort of some sort of internally, privately IP'd solution that's now speaking to some host that's living out in Germany. And as we watch the conversations take place, we see that there's actually an indicator match. So we've got some threat intel that's there that's telling us if you see things reaching out to this particular domain, let me know. Sure enough, no sooner does that connection actually occur, and this is all HTTP traffic that we're seeing here. So we see the initial indicator come from DNS, then we see this HTTP conversation where we're getting actual packet level alerts taking place here, where we see things that are reminiscent of this maldoc being
moved. Seeing executables packaged in things that don't look executable.
Correct. And then we continue to walk down this path, and we see eventually that the system has built out this file that was crossing the wire, and it is being MD5'd, and we see a match there, and then we actually see that the math problem has determined that this is also a suspected piece of malware. So it's a great little, in the course of just a second and a half here, we've got a string of events that kind of lead us to believe every one of these things is important.
And I noticed, just as you're talking, you mentioned the math problem, but I see over on the left side here in the tags, we have this target, a little bit on the actual tag column. Yeah, if you want to just kind of tell me a little bit about what that means.
Oh, this side of it you're saying here?
Yeah, that's kind of what.
Yeah, and you're looking here. I'm sorry. So yeah, that's great. Well, so this is going to kind of step into the ways that we've tried to make life easier for the analyst. So we have this notion as we're building out all this body of knowledge about the network and the alerts and everything else. Excuse me, I'll grab a sip of water here. But we realize that you're going to want to be able to manually interact with these alerts as they're coming in. So being able to tag those alerts with information that's relevant to your environment is important. So adding context using the tags, and then we also have a method of programmatically tagging these things. So in this particular case, we've got a filter in place, or a tuning filter, or essentially a tagging filter, where we say anytime we see something that is malware related, go ahead and tag this with critical malware. And this becomes a very good way for us to quickly isolate or filter specifically around malware alerts that we're seeing as an example, or focus our attention to things that we care about that are contextually relevant. I'll show you some great examples of using this for metadata, because when you start thinking about looking for anomalous behavior, there are all sorts of folks and there's a whole group of organizations that work very hard on machine learning techniques for understanding anomalies. But at the end of the day, An anomaly is anything that's not normal, and if you can tag all of your normal traffic or stuff that's authorized, you can remove that from what you're looking at and immediately understand what's...
Sort of the whitelisting rather than blacklisting approach to identification.
Yeah, absolutely.
Sure.
But
and one of the things that I really enjoy so far is the idea of, like, we haven't actually gotten into any packages, we haven't done any deep, like, individual analysis, just sort of looking at what is displayed on this immediate screen, just seeing there's context being built, there's a story already kind of being told with this tool, and I find that fascinating.
yeah, well, and it's something that we continue to try and improve upon as we build out visualizations for the solution and connecting the dots. Those are all things that are really important. Telling that story, at the end of the day, if you want things to get done, you have to have a good story. So, working through a few of these, so if I were just to jump into, I'll just use this guy as an example, this maldoc alert. I think your traditional IDS or intrusion detection system does a nice job of letting you know that there was an alert, just as you're seeing here. And then you'll get this sort of basic 5-tuple or flow tuple, as we sometimes say. But you're really basic. Who's involved? What ports and protocols are they using? Applications, things along those lines. But a lot of the rest of it is then up to you to go try and uncover using the rest of the tools that in your arsenal. And so what we've done then is correlated these alerts. So taking the signature-based alert and now tying it back to all the metadata that we're extracting in the traffic. And so here, instead of just having alert, you get to see, for instance, that this was an HTTP communication, which might be self-evident that is over port 80, but in fact is not always true. I can show you some good examples of encrypted stuff running over 80. You can see where this, the host that this system internally was talking to. We've got a GET request out to the toptrends.org and then this URI. So all this information is really valuable if you're trying to make sense of what this alert is about and whether it's relevant to your environment and whether an action needs to be taken.
You're sort of kind of going back to that idea of building the story.
Building the story, precisely, yeah. And this is where tagging becomes kind of a nice feature. These are all customizable, so you can put in here whatever you like. But if I'm an analyst and I'm working on this thing, I want to let everyone know that I've seen it, so I tag it as seen. And then I'm telling folks I'm investigating, and I can say I think this relates to a few other things. And then
people a couple of tagging systems, maybe a Kanban board could get thrown out the window.
Yeah, precisely, exactly. And the great thing here too is these all this tagging that you're doing can be exported from the product as well, so it's doesn't have to live here. And then this notion of okay, I maybe having 200 alerts that we had in the background, maybe I want to actually go ahead and focus my view now on just what's happening here at the sales terminal. So I can start to actually use all these to create filters or pivots. We've got this notion of a shoebox, which is this notion of an analyst shoebox. It sort of comes from years and years ago working with a lot of threat intel analysts where we were perpetually, everything lived in an Excel spreadsheet. Everyone was passing their data. All the data foraging was done from the Excel spreadsheet. When you found something new, you brought it in, you added it to the list of stuff, you threw things away, you added stuff. So all that's
an extremely manually intensive process for those who've not had to experience it.
Yeah, very manual, and also prone to different versions. So losing version control of that and having somebody running off of something and not adding to it or not getting their stuff. So anyways, we created this idea of a shoebox, and that was actually the analyst shoebox was this Excel spreadsheet for years as we would pass this thing around. But in the product, we thought, if you're moving at the speed of thought through an alert and you look at some feature here that you want to be able to come back to down the road, wouldn't it be nice to have a landing spot for that? So you can go ahead and just throw this into the shoebox. That becomes now a feature of, and I'll show you where the shoebox lives, but it's now this scratch pad that you can use. And I would say it's shoebox version 1 because there's a lot more that we can be doing with this idea of data foraging and storing data effectively. But going back to your analyst working through this particular alert, he or she has left some tags. They might even be asking the question like, what is this alert? Here's a big message here, but it doesn't mean anything to me. So if I want to actually view the policy that triggered this particular alert, I can click right into that and I'll be brought over to a screen. And you'll see here that for the signature-based component of things, we're leveraging Ricatta in the product. So if you're familiar with the way Ricatta rules are built, you have access then to this Ricatta rule. And if I want to make changes to this because it's noisy or it's no longer effective. I can actually do that. But more importantly, I can come in here and I can see very quickly, is this something that's based on like IPs or domain, or is there some more meat to this? Is it really looking into the packet? Yeah.
Textual search.
Yeah, right.
Okay.
So that becomes a really helpful way to investigate and understand what these alerts mean. Going back to that alert that we were looking at, I think we've more or less done everything we needed to do here, but you'll see this big red hunt button and this notion of PCAP. So if at some point I were working through here and I decided I did not have everything I needed to, or there was a question I had about this metadata that I was looking at, I can always go back to the actual PCAP itself and pull that up. And this is great here. It all lives in the same system. So I hit this PCAP button and off it goes and downloads. And what we do here, what we call Smart PCAP, is anything that's contextual and associated with an alert. And in this case, it's 11 seconds left and right of center, because everything good is in
It's going to happen
right around 11.
So that's kind of how you guys found it.
Or 42, right?
So that's how you found to kind of split that difference in terms of, PCAPs are the most information, but there's too much data to store and that sort of thing.
Yeah, right. I mean, everyone is storing petabytes and petabytes of information for that needle that is oftentimes kilobytes large. So if we store a whole bunch of needles, maybe one of them's the right one.
It's a much less pleasant stack to search through, but you're probably going to find which needle a little bit more quickly.
Yeah, that's the hope. So, and then being able, of course, to just jump into whatever your PCAP analysis tool of choice is, but being able to pull those up and very quickly move into that is great. So we talked about PCAP, and then this big red hunt button. In this context, it's a bit more of a response button. I've got an alert and I'm responding to that, but the idea here is that I can go straight from an alert into all of the associated metadata around these assets involved in this. So I'm going to hold off hitting the hunt button for just a second because I'm going to jump into one more alert and then kind of demonstrate how that hunt works. But again, alert-driven approach here. We've gone ahead, we've looked at the opening alert and this salvo of stuff that appears to have been generated by the communication with this host here in Germany. Another signature-based alert, several more of those, and then we jump into this suspected malware alert. As I jump into this, the context is a little bit different because we now have traffic that's actually going to the sales terminal. And we'll see here that we've got all of the same sort of metadata here, but now we've got an MD5, which might be a very useful place if you're worried about this malware having executed somewhere downstream.
Very rapidly hunt through for this hash.
Yeah, precisely. So you'll use your endpoint tool to go ahead and do some searching there. And then we've also got some interesting information here that's provided to us by the Infinity engine, which is what we're using to do some of the math problems. Okay. Infinity engine, by the way, is Cylance's engine that they use for math problems.
Malware-related math problems, but yeah.
Yeah.
Speaking of malware, I'm probably skipping ahead a little bit, but I did notice that another button appeared up at the top when you open the specific.
Yeah. Let me run to the top there. I'll show you. So that is the malware button, and this is kind of fun for us because we actually go ahead and leave that file on the sensor. It gets quarantined and zip encrypted and password protected, and that becomes then something that you can leverage downstream with your reverse engineers on the team or send it over to your sandbox environment.
Kind of once you pass out of the triage stage and you want to do a little bit more deep analysis.
Yeah, precisely so. And we see a lot of people doing some really interesting things with this old methodologies. I think there are a lot of folks that are of the opinion that if I've not seen this file before, it needs to be analyzed and I need to throw it to a sandbox and I need to see what it does when it's opened up.
Break it open with my own two hands.
And that can be, and then they immediately run into the problem of files being large or inflated or padded or whatnot, and they start setting size limits, and all of a sudden they're only looking at things that are 5 megabytes and smaller, or as an example, or you pick your number. But what's great about having this sort of triage to it is that the Infinity engine does a really nice job of calling out things that are interesting, and it's got a 1 to -1 scoring system where they've set the level at anything that's a -0.8 or below becomes something that's considered suspicious. But you as an organization could choose any number, any point in that continuum to make a decision about, hey, that's a file I need to spend more time with. And that's what I think is interesting about this, where you can start to create nice triages for suspected malware rather than relying on doing, sandboxing every single thing. Yeah.
So that 1 to -1 then is where you kind of start implementing those Bayesian math problems and
right.
digging into. Okay,
right.
Fantastic.
And you'll see that here, where there's some nice features of the file and what Infinity Engine is showing us is saying.
See what the input decision-making data was based
Right.
upon. Okay,
Right.
fantastic.
Another thing I'll just point out here too is this data is all exportable from the system, so everything is in the JSON format. So if you ever wanted to know what the data looks like when it's leaving the system, you've got a good example of it here. All right, so you can imagine yourself being on the receiving end of this alert. You've seen several things that lead you to believe this is definitely worth your time to investigate. And now you're wondering, what is it that may have just gone downstream and executed? And so the first question you might even ask is, what about this host? So this notion of researching things comes up all the time. And for us, being able to take information here and pivot out to another data source is often very useful. So this is all totally configurable. And when we work with government customers who don't necessarily always like to reach out, they might have their own sources of data that they like to look at. So this becomes a great way for you to pivot internally if you've got your own space or your own repository of information that you don't want to necessarily tip your hand to what you're looking at. A couple things kind of going on there too. So we'll passively collect DNS information as we watch the conversations. That's kept internally. If you want to go ahead and ask the system to do a reverse lookup for you, you can do that. And it will tell you whatever it's seeing at the time that you hit that button. You can also then go to any of these, like I've got Virus Total here. I think that's a great starting point for a lot of interesting investigation points. So we see, yep, sure enough, this is a host that's tossing all kinds of bad stuff out the door. If I go ahead and actually bring that particular MD5 into the view, we can start to see, yep, this is the Lockheed Trojan, potentially ransomware here. So I've got a whole bunch of new questions I might be asking myself. And when I do that, I guess one of the things I start thinking about is, okay, if it's ransomware, do I need to worry about this being self-propagating? I could go do some research on the actual sample itself, but immediate question, is this something that's self-propagating? Do I need to worry about it communicating with other internal systems? So this is where
it kind of helps to build more of that context of how do we respond in the short and near term, kind of what do we need to do about this problem?
Right. And so for me, I get to go ahead and hit this nifty hunt button, and I say, well, I'm most worried about that sales terminal and who it's talking to. So I say, let's hunt around that destination IP. And I'm now pivoted to our metadata view of the world. And so this is all of the metadata that we're collecting. We've got a really truncated sort of conlog view of the world, connection log view of the world. But what's great here is I'm starting with a very small snapshot from a window of time, but I can open and close this aperture to bring a much larger picture into view. A lot of times stuff's happening far in the past that I need to make sure I'm aware of. I can organize this data differently where I can say, why don't you show me everybody that system's had a conversation with. And now I'm provided with this sort of breath of relief here where I can see, it looks like everything that it's communicating with is external, except for the gateway here, which I'd expect. And okay, so now I just need to go yank that system and clean it up or image it and do what I'm going to do.
Yeah. The entire department for a day as you.
Yeah. So, and if you think about it, that was in relatively few clicks that I was able to come to those decisions and work through all of that. So really, again, what we've decided or tried to do here is make, again, all the things that an analyst is going to want to work with or the information that they're going to need to answer questions readily available within.
Do this with a cup of coffee in your other hand.
Yeah, exactly. I'm going to steal that. So that was, I mean, that's one way of walking through the product. And I think we spend a lot of time with prospects and with customers just helping develop nice, clean workflows for them to move through simple analytic questions. We've started to develop different types of visualizations that are useful from a pure metadata perspective where, like, for instance, user agents are a great question that everybody has. Threat hunting at the end of the day is a whole lot of counting. It's counting for things that you're seeing a lot of or very little of, and those are the things that are oftentimes the most interesting. So, being able to immediately figure out, and maybe you ask the question, who the hell's using curl in my environment? That doesn't. That's not a tool that my sales team needs. Exactly. Or if you've got a torrent agent running off of a database, that might also be interesting. And so these are quick and easy ways to kind of figure these things out and build out visualizations to go and build filters out that will get you to these things quickly. The other thing that I think is really exciting about the solution, and this is where the threat hunting happens, is in the metadata. Threat hunting for us, the way we would define it is in that assume breach mentality. You have to start trying to you have to be able to find these adversaries doing what they're doing, and your goal now is not to prevent them from getting in, but to prevent them from completing their objective, whatever that might be. And then as a byproduct of that, develop detections and automate those detections so that in the future those aren't things that you have to continue to manually hunt for.
Sure. To abuse a buzzword, sort of focusing on that defense in depth concept.
Absolutely. I didn't say it, but yeah, you're right. And so to do that, you need to be able to create a framework for conducting those tests, or those, have hypotheses that you can test, have a way to test those. There are some great frameworks out there. I talk all the time about MITRE ATT&CK and other ways of coming to the problem.
Approaching the question.
Yeah, because otherwise you'll spend all day and reinventing the wheel over and over and over again if you don't have a really strong beginning, middle, and end to the way that you work with this data. But there are some great questions you can start to ask yourself. So in this environment that I have, and of course I've got really ugly data running in the background on a replay server over and over and over again. So a couple of things happen. You get some stuff that looks very repetitive from a visualization perspective, and I can always find bad stuff. But another huge thing about the notion of threat hunting is it really gives you a sense of the environment that you're working in. So there's no better way to learn what normal is than to spend a whole bunch of time diving in deep, looking for things that look a little bit unusual, and really running those all the way to ground.
One of the things that I talk about a lot when I'm teaching courses, or when I'm kind of giving people advice and security consulting, is this concept of when a parent's child, and we were talking about you have a couple of kids, and when a parent's child has a sore throat, the first thing they do is check their throat and realize they have no idea what a normal throat looks like. And so one of the ideas here is building that baseline knowledge of truth. Like, this is what a normal day looks like. So when the system is sick, we can identify what those symptoms are. Right?
That's right. That's right. And what's even cooler is you can start to develop ways of tagging what normal looks like. So I have some good examples of that. I wanted to start just by saying, we've got all of these great filtering and grouping techniques and tagging techniques that we can use. But if we're just looking at the data itself, a big wall of data can be pretty daunting. And this information is really only the tip of the iceberg. This is straight connection log information. It's not even providing us detailed information about the size of the communications that are happening here or anything like that. But when you start thinking about specific problems, and when people go into hunts, oftentimes it's based on an advanced tactic or technique that they've seen used, and they want to see if that's being employed currently in their environment. DNS is a great space to spend time because there's so many tricky ways that people have been abusing the DNS service forever. And
such a baseline. DNS isn't something you can comfortably just turn off to get rid of the threat. Yeah.
And it has, and every environment has it too. So
right,
there's
exactly.
So what's cool here is we are extracting all of this metadata from the solution, and I've created this view of the world that I've got right now is based on these little these selections or fields that I've put into this view right now. But I can enhance that in a variety of ways. And so if I'm interested in information that lives in my connection logs, or the data type of conlog, and you're going to see if it's not obvious, the metadata that we're extracting, we're doing that with Bro, or Zeek as it's called now.
Yes.
And so Zeek is providing us with all this information. What's great about Zeek is as you script out new analyzers and new log features, those are all dynamically added to our solution. So in that way, you don't have to do any kind of tricky massaging of things. It just, if you've got the log generating or if it's generating some sort of feature, we're collecting it and monitoring it here. Excuse me. So we were going to talk about DNS for a second, and I guess one of the fun things to do, so I can go grab DNS. You can see I get a whole bunch of new features that I can start adding to my view of the world. I can create something that has my DNS requests and responses in there. So maybe I want to go ahead and add those to my list of stuff that I'm looking at. And I could keep pulling stuff around here, but you also have the ability to save things that you use all the time. So I'm going to do two things. I'm going to start with actually this little beaconing view of the world, which is something I use just to look at the size of conversations and sort things in interesting ways. So now it's that traditional 5-tuple, but I've also got the size of the conversations added to this. If I want to go ahead and open up some filters, I can say, why don't you show me everything that's DNS related? So I'm not going to do that. problem with live demoing anything is the mistakes I will make on the way.
That's fine. We'll fix it in post.
We'll fix it in post.
That's fine. No worries.
No worries at all. So, again, you remember that FBI story I was telling, how it was a whole bunch of folks saying, we don't even know where to figure out where that request is. Well, I'm looking at the traffic here. I can pull up the service here with the request. I can start going ahead and saying, show me all the requests, and this will all just be added in my view of the world, and I can start filtering directly on that, and I'll be able to pull up anything I want. So that is a fantastic thing. But if I'm looking at these DNS requests, or these the DNS requests that are happening here, or just DNS conversations, one of the things that I've done in the background is I've gone ahead and said, if I have a request being routed through the name servers the way they're supposed to be, let's just check that as an authorized DNS request. And so I've created a filter in the background, this authorized DNS filter log, where I add a tag to anything that is one of those name servers that I believe to be authorized. What that does then is generates this little tag for me, and just a nice little green thumbs up. And one of the things I can do is actually create a view of the world now that shows me all of the stuff that is authorized, but more importantly, I can show all the stuff that is not authorized.
So a nice Boolean, straightforward, just and or not.
And or not. Super simple filtering setup here, but super valuable in the sense that, we a lot of malware and a lot of tools, in order to see whether they're on the internet, will do just a quick hard-coded query to Google or to others. Sure enough, you're seeing exactly what you'd expect in a dirty environment, is a whole bunch of stuff that's not going the way it's supposed to. And this becomes something that you can quickly start to organize in ways that are interesting. So maybe if I look at everything based on the size of the communications as a starting point, stuff that's big and ugly, I can jump into this, so something heading out to Google. And now I'm looking at that connection log, so you can see all of these different metadata components. But as we jump down into the DNS-related components of this, I've got stuff that, you have to know your environment better than I do, but a whole bunch of high entropy stuff reaching out to.
.ru is the safest address I've ever seen.
Or and all the weird local domain stuff that's happening there. So this becomes, obviously, just without having done anything but a couple of filters, I've uncovered something that I should probably spend some time looking into and running to ground. And again, having access to the raw PCAP, I don't know that DNS PCAP's always very interesting, but it's there.
Sure.
And taking this a different direction, one of the techniques that we see used a lot now are sort of DNS covert channel stuff, which inevitably has some size associated with it. So one of the things that you can do quickly, if I already have this stuff sort of organized by the size. If I were to jump into these really large conversations that are happening between these.
DNS communication.
Yeah, well, what is going on there? And we jump in here and we see all of this encoded crap in front of. I happen to know this is DNS cat in the background, but you can see here that you've got a bunch of encoded stuff happening in the subdomains here, and then this rarely used text feature in the response coming back and providing instructions back to the host. So again, you're
kind of identifying covert channel command control
with just a couple filters and some lightweight engineering. So
I can think of days in my life where I would have killed for that.
Right. And I guess the takeaway here, though, is it's easy to find things, and then you have to start thinking about ways that you want to automate some of this. So you don't always want to spend all day long applying filters and running through these different workflows. And so, one of the examples I have, I wonder if folks, are you familiar with the whole JA3 SSL profiling or TLS profiling techniques that are going on here? Yeah. So they've done some really cool work. These are the Salesforce guys that built out some modules for Zeek that identify. I don't know how much of this we want to.
Zeek, for those watching at home, Zeek is the new branding, the new name for Bro scripting, for those of you familiar with that.
But if you dig into some of these, the notion is this, that as encrypted communications are stood up, there's some transferring of the keys and other pieces that are done out in the open. And so if you are able to then concatenate a bunch of those features and hash those, you can start to identify the way that an encrypted channel has been stood up. And things that are hard-coded to stand these things up the same way every time, which is just about everything. All your not even your plugins for your basic web server, your Salesforce plugin, and your this, that, and the other thing. All of those things have a standard way of standing up their encryption when they create encrypted channels for you to communicate.
So even if you can't crack that encryption, you're able to kind of get some fingerprinting knowledge out of that.
Precisely, yeah, and if you can identify stuff that is known bad in the environment, the way the interpreter is going to stand this thing up is going to be the same way every time. If you want to stand up, or if you've got some communication that's happening now, some sort of DNS, or excuse me, some encrypted tunneling taking place, you can start to shut that stuff down very, very quickly using that technique. So, and Ricatta today has a hook for that, so that you can actually start when you're in line actually blocking based on JA3. So I point this out only because, again, I've saved some filters. This is another great thing about the product. I don't have to go and rebuild these filters every time if I've got something I like to use.
Especially not on camera when
Right.
everything always goes wrong.
So this is one of these, like if we want to walk through how I ended up here, I started with a conversation with this data saying, hey, I guess I'm just interested in looking for encrypted communications that aren't taking place over 443. And as I started looking around, I thought to myself, maybe stuff that's really obviously wrong. So encrypted stuff that's taking place over port 80. And in my environment of dirty things, you immediately see that I've got this communication that's taking place. And it's interesting, right? Because it is something that is, if we look closely, happening every, I need to organize this by time. So we've got something that's happening every 5 seconds. We have something that's identically sized for every single one of these communications. So this feels very much like a little beaconing tool, which it is. And this is PS Empire. But if we open this guy up, and in fact, I have an alert for this already that we've built, but if I open this guy up, you can work through here and you can start to see some of the features. And one of those, that JAW3 piece that I was talking about here, is right here. So this is one of these things where when you're trying to come up with a way to automate at least the detection of, this is a super heuristic and very lightweight signature style approach to this, but I can just take this J3 and throw it into a Ricatta alert, and I can start alerting on anytime I see this, or blocking this anytime I see it, effectively totally disrupting that adversary's way of
and very,
communicating.
Very, focusing on that scripting and kind of removing that from your day-to-day job.
Right. Yeah, exactly. So we've talked a lot about the alerting side of the house. We've talked about the metadata side of the house. These were some of the big tools that we thought that we know are important for the analysts to do their job for just simply tracking things down and their incident response work.
Sort of what we're talking about, that kind of cyber hygiene and just your day-to-day work as an analyst, and keeping your environment safe at a basic level.
Yeah, and then being able to pivot and get a whole lot more detailed and deep in the details here. So the final piece of things kind of then, how does this system work, and what are we talking about from an architecture perspective? Well, the system's designed with a central management console, which provides you this view of the world here. So it's responsible for the web UI. It's also responsible for acting as the front end to a lot of the searches that are taking place in the various database components that we've got in the back end. You can actually manage hundreds of sensors with a single CMC, which is kind of nice. So you can build out some pretty extensive sensor grids here. And then not every sensor is going to be tasked with the same things. That sensor that you've got living in a DMZ, if you choose to do something noisy like that, is going to be very different from what you're doing at the core, and it's going to be very different from what you might be doing in your PCI zone or any of those. So being able to create policies or taskings that are specific to that sensor and where it's located is another huge piece, and that can all be organized in one spot is what we've tried to do to make the analyst's life easy. So being able to drill into the sensors, being able to open them up and understand what sort of load each individual sensor is under, the amount of throughput that that's seeing, being able to then manage the data clustering on the back end as well. All all of those are sort of the enterprise features that are built into the platform, and maybe less interesting to the individual analyst, but nonetheless really important.
But I mean, they're very important to the security architecture specialists.
So so that's high level, the alerting and the visibility and this notion of a comprehensive threat detection capability. And then building all these different pieces out becomes work that you're doing in the policies. And so we saw that there was a lot of alerts there. We saw that there's tuning that needs to be done. That can be done in a variety of ways. That can be done enabling or disabling rules that make sense for the environment. Running a whole bunch of ActiveX rules with no Windows systems is probably a waste of your time. Things along those lines. You also can bring in your own rule sets. So importing is something where we'll check every hour against the different rule sets that you have out there. And in post, you might hide this. Actually, we'll just cut this whole screen. But being able to choose the variables that are specific to that particular sensor. So this is a really important piece for context. If you put a sensor in that doesn't understand what external net and what home net is, or where the mail servers are, or any of that sort of thing, you're going to find yourself either getting alerts that you didn't want, or the other way around, not getting alert when you needed it.
Context without that sort of core information. Absolutely.
Being able to geo-IP your own private IP space is a really nice feature. So providing lat launch for all the different systems that exist in your environment. If you've got stuff living in Vegas, Reston, and Austin, you want to know that that's where that stuff's coming from. And that actually feeds another fun visualization in the product, which is this geomap. So if I pop open the geomap here and bring the screen down, you can start to see, if I know that Reston or Mountain View is only supposed to talk to Austin, and Austin's only supposed to talk back to Mountain View, but is now communicating with all of Eastern Europe, this becomes one of those things where you might say, hey, what's going on here? And start to, have geo visualizations driving an analyst workflow.
So this is the map you leave up on the big TV with the investment.
Yeah, it really is. It's our pew pew map. There's I guess.
Pew pew. I'm stealing that. We have a trade.
Okay. So and this is the pew pew map with actual data. There's the other caveat here. There's been those in the past that sometimes data was suspect. So so that's where we're living from a policy perspective. We can tune what data lands on the disk and what does not. You can, of course, choose where you want things to be exported. I'll point this out only because it's nice to know. When we're working with exporting data, we actually provide data in the form of syslog, which can be pre-formatted to most SIMs that are out there. For Elasticsearch, where we've got the appropriate index rotations tied into the headers there, and then just raw JSON as well. So this is the sort of thing that would feed a Splunk implementation or something like that. And then speaking of Splunk, it's worth mentioning we have a TA for Splunk as well. So moving all that data into the common information model is
that was actually one of the questions I had was, how well does this integrate with tools like Splunk that are doing sort of
that roll up for people? Yeah, and again, we're just the network side of this right now. So at the end of the day, I think from my vision perspective, it's being able to interact with whatever larger workflow that an organization may have, being able to provide their data lake solutions with clean data, and then also being a place so that an analyst can come to and navigate through all this data in a very specific way. Yeah. So I think that is I think you and I were trying to spend some time here to make sure that you had a good understanding of the product.
Yeah, absolutely. I think I'm definitely. I love the context building and the application of all these different sort of. Kind of what we're talking about is just the concept of building a story with your scanning tool.
Right.
So I've seen. I mean, obviously, I make tool videos as a huge component of my day job. So I've seen hundreds and hundreds of different. Here's all of the data on your network, or here's what we think is the important data on your network. And I like the correlation and the context that's created here. Fantastic.
Well, great. Yeah. So I think. I'll stop sharing now.
Yeah. All right. So I think, do we still have, okay, I was worried for a second we lost our studio. I think, obviously, we talked about that tool and we got your elevator pitch from it. So one of the things that this is, this is probably primarily like an enterprise solution in general cases. This isn't something that
Absolutely.
So, what I'm curious about it is when we're talking about tons and tons of analysts working together, and you talked about that workflow creation there, how role-based, and probably bad to ask you this after we already left the tool, but how role-based is it? How much are you need to and have to see of data and of configurations, that sort of thing?
Yeah, so the role-based access piece, I'll show you here again, but it's included in the product, and so the granularity of those roles is always something that requirements change from customer organization to customer organization. So we've got built in what we think are the foundations for a strong role-based access program. Things like only limiting access to alerts to those that need it, limiting adjustments to the alert or the rules themselves to administrators specifically assigned to that task, and then being able to see who's made changes to what is all built into the product.
This leads back to the reason I asked that specifically is it leads back to the story you were telling kind of way back when we started this conversation of security teams were being siloed off from key information, and companies that are still nervous about don't want to expose business context or business information or communications that are privileged or things like that. You still have that ability to do that while still capturing that data and just being able to control who actually touches it.
Right. Yeah. So it has those rudimentary components of role-based access. Yeah.
Yeah, so I think that's really what we've got. Obviously, we'll edit some together and turn this into a proper breaking stuff video.
Cool.
So people got to see a great behind the scenes working with, again, this is Kent Wilson, VP of it's customer experience or senior intern of customer experience.
Yeah, no, I was going with junior analyst. Yeah,
Junior
exactly.
analyst, there we go. Yeah. Fantastic. All right. Thank you for coming in. Really
Thank you.
appreciate it.
Perfect.